All right, we've discussed a lot about linear functions. We're going to start graphing with the T-table. We're going to graph linear functions in several different ways. The reason why we go over T-table first, even though you've done it before, is because every single graph that we do this year, we're going to usually start out with the T-table because it's easier to look at a T-table with an unknown graph and graph that. Okay, and so this is what we're going to do. Okay, we've seen T-tables. T-tables could look like this. Or sometimes people do T-tables like this. Okay, and then where we're just going to have sets of points. Kind of like that. Okay. Okay, what we're going to do today is we're going to do a double T. So normally your T-tables look like this. Today we're going to do a double T. And I'm just going to kind of show you how we're going to do this thing here. And so we're going to start with this first problem on your thing. Okay, and I'm going to show you how this double T is going to work. This is going to be x. This is going to be 2x minus 1 equals, and this is going to be y. Okay, so basically in the middle of this double T table is where you're going to do the function part. Okay. This would be 2 times negative 2. This would be negative 5. This would be negative 1. We already did that one correctly. This would be okay. So we got all those points. Okay. That looks good. All right, so let's graph it. Let's graph these points on this line, right? On this graph right here. That shouldn't be too bad, should it? It should be 5 points is easy. Negative 2, 5. Negative 5. Right here. Let's try to get it all on the same thing. Negative 1, negative 3, sure. We're gonna connect them, and I'm gonna show you that in a second. 0, negative 1. 1, 1. 2, 3. Okay. They should be a straight line because we're dealing with only linear functions right now. So if it's not a straight line, then you did something wrong. And we're supposed to put little arrows on here because it goes on forever. Okay? Here's what I don't want to see. I don't want to see where you do this and just do like where you just connect the dots like this. Okay? Make sure you extend it past the dots, put an arrow. Okay? And this is what I'll see on the test. I'll see someone do this. Okay? They messed up. But instead of trying to fix it, they're just going to go, it's got to be right. So they do this. This is another thing I see people. This is another thing I see people do in their homework, and they think they're going to get away with it because apparently they think that I'm not smart enough to know how to do this. They'll do this. Okay. Maybe they're the answer, sure. But it looks to me like they just didn't do anything. And so I'm going to look at this and go, okay, what happened? And then I'm going to look at their T-table and see if their T-table or however method I have you graph it looks. And so this T-table and that scribbly line doesn't match. Okay, it's close, but doesn't quite match. So don't do those things. Okay? Just go ahead and see, you see my points, don't you?
Yeah.
They match my T-table. It looks like I did my job. Yeah. All right, let's move on to this one because this one looks hard. And probably what you guys are going to do is instead of using a separate sheet of paper, you got plenty of room right here to do your T-table. You technically do. But I got a problem. I have a fraction. Okay? And so let's say I use -2. So -4/3, let's see if you can see this. -4/3 times -2 plus 1. Okay, I got a fraction, don't I? I could change it to a decimal, but then I have 3.6. I don't want to graph 3.6. I don't want to graph things that are crazy fractions or decimals. So I need to be able to fix it, and this is how I'm going to fix it. I'm going to take this number right here, and I'm only going to use multiples of that number. Okay? But multiples, this is what I mean. 3, 6, 9, right? So this is what I'm going to use. -6, -3, 0, 3, and 6. So this is going to make your fraction go away. That is our goal, is to kill the fraction. So see if you can get this done real quick. This way of graphing is definitely a little more time consuming, but it is one of the ways that we need to do it. And actually we'll begin and end with this, because when we start doing non-linear graphs, we're going to start having have to do the T-table just to look at them. And if you want to do this quick in the calculator, this is what I do. -4 times 6 times -6. And I just do one thing at a time. Divided by 3. Am I allowed to do 4 times 6 divided by 3? Instead of putting 4/3 in the calculator?
Yeah.
Can you put 4/3 in the calculator?
Yeah.
Okay. It just doesn't matter. So this is going to be 9, I think. Is that right?
No.
-4/3 times -3 plus 1. It's going to be 5.
Yeah.
Yes.
There's just one problem. It goes outside the grid on the paper.
Well, and we'll talk about that in a second. But you're right. It is going to go outside the containment. Okay, and then this is going to be -4/3 times 0, like I said. It's going to equal 1. This is going to be what, -3? And this is going to be a -7. Okay, he did bring up a good point. I don't know if we could hear it, but the point is that some of these points will be off the grid. So like -6. Okay, I guess I can't graph that point, but I have it in my table to make sure things make sense. Because remember, a linear graph goes in a pattern. So this is add 3, add 3, add 3, add 3, right? This looks like it is subtract 4, subtract 4, subtract 4, subtract 4. So I can check my numbers here. 5 gives me a good pattern, so I can't graph that one. It's okay. Negative 3, 5, I can graph. 0, 1, I can graph. 3, negative 3, I can graph. 6, negative 7, I can't really graph because that would be like here. I guess I could do that if I wanted to. But we do see it makes a straight line. And I met the requirements because I'm making you do 5 points. And we'll put a little arrow there and we win. Okay. And so here's the last type of problem we're going to go through. Okay, this one is problematic to me. Okay, we could, and I'm going to go ahead and move back to my paper so I can show you this. We could, I'm just going to do the negative 2, negative 1, 0, 1, 2. And this, I'm going to do it this way just to kind of show you. Some people have to do it this way. I don't like doing it this way, but some people have to. So this is what I got. And I don't really like it like that because this is going to cause more work. So I could do this. 3 times negative 2 plus 2y equals negative 4. Negative 6 plus 2y, well, I guess I need more room, equals negative 4. 2y equals 2. Divide by 2, y equals 1. Okay, do I have to do that much work for all 5 of the points? I would have to, wouldn't I? Or, at the end of the last chapter, didn't I make this easier by saying to you, solve for y? Can we solve for y real quick so I don't have to do this every single time? Wouldn't that make my life easier? Let's solve for y. Remember, we do what to both sides? Then I divide by 2. Well, this is a good sign anyways, because now I have a fraction, and I hate fractions, so we're going to have to kill it. But this is going to be way easier to do in a T-table, isn't it? So I had to do the work, but I only had to do the work how many times? Once, even though I need to do 5 different points. So now I'm going to make the T-table. See if we can get this done. And let's see if we can pick the correct numbers. I heard one of the numbers we're supposed to pick is 4, right?
Yeah.
Does this look good? Where did I get those numbers from? From this guy right here, right?
Yeah.
2, 4, 6, 8. Let's just do those. Because if I picked 8, it wouldn't fit on the graph. Okay.
Wait, it's not linear.
What's not linear about it?
You added 6 and then you just went up by 2.
We're It's linear. Negative 4. Yep. What he probably meant to say is I'm supposed to do this. I forgot my negative sign, right? Okay. Of course, I wrote this here where this is supposed to be a negative 4. It's supposed to be a negative 4. And so that's going to be negative 8. That's not going to fit on my graph. That's okay. But good catch on this. I messed something up. I had 2 2s. One should be a negative. This would be, what? No, that's not a negative 8. Who let me call that a negative 8? What is that? What is it? Put in your calculator. Don't wait on me. Is it 4? That's much more reasonable. All right. This one's going to be now this one is going to be a negative 5. And this one is going to be negative 8. Okay, graph it on this thing. See what we can do. And believe me, this way is way faster than doing it. So there is a purpose in what we learned. It is for speed. Make it less work. All right, I think should be negative 4, 4. Negative 4, 1, 2, 3, 4. Negative 2, 1. 0, negative 2. 2, negative 5. And the last one won't fit. So fractions are no big deal, if you remember that trick. Okay. That's it for this one.